All right, class, we're gonna do real quick H. I'm gonna try to be real quick. So the problem is 1.374 times 10 to the negative second meters cubed. Guys, I'm gonna go pretty quick on this A because my battery's dying, and B, it takes a long time to upload whenever these videos are long. So first of all, I'm looking that I'm in meters cubed and centimeters cubed. I gotta switch one of them out, right? So I'm gonna actually, it doesn't matter which one, but I'm gonna switch my centimeters to meters. Okay, so I've got 7.11 times 10 to the third centimeters cubed. I'm gonna translate that, okay, to 7110 centimeters cubed. Again, I just moved the decimal over 3 places, 1, 2, 3, okay? And then I need to get rid of my centimeters cubed. I'm writing 3 here because I've got 3 centimeters that I need to put on the denominator to get rid of. And I need to go to meters. So I'm gonna look at my conversion factor that is between meters and centimeters. You can use either 0.001 meters per 1 centimeter or 100 centimeters per 1 meter. It's up to you. I'm gonna be using this one. So I'm crossing those 3 out because cross canceling, I've got 3 of them down here and I'm gonna be left with meters cubed, which is what I want. So whenever I look at this, I've basically got this problem, 7,110 divided by 100 times 100 times 100. You can stick that into your calculator, or you could just move your decimal place 6 places, right? Because I've got 2 zeros, 2 zeros, 2 zeros. So if I do that, I'm going to be left with this because I moved my decimal over 1, 2, 3, 4, 5, 6. Okay, but then, guys, you're not going to have a problem this hard on the test. But then whenever I'm adding or subtracting scientific notation, I want my tens to the exponent to be the same. Okay, so I'm going to, let's see here. I want this to be to the 10 to the negative second, right? Because that's what I've got over here. So I'm going to move this over 2 places. So that's going to give me 0.7110 times 10 to the negative second, right? Because this number theoretically is getting bigger because I'm moving it over 2 places. And so then my exponent needs to get smaller, okay? So then I'm at 0.7110 times 10 to the negative second. Now I'm in meters cubed, right? And then we were supposed to add that a long time ago, way up here, to 1.374 times 10 to the negative second meters cubed. Ta-da! Now I've got a problem I can work with. I'm in meters cubed. I'm in 10 to the negative second, 10 to the negative second. And again, that only matters, the 10 to the negative second, 10 to the negative second, if I'm adding or subtracting. So now I can add my 1.374 to this number, and that's going to give me 2.085. I'm going to look at smallest decimal place, 1, 2, 3, 4, 1, 2, 3. So I'm going to have 3 decimal places, which is great because that's actually, you know, there was a 0 there, but that's actually what it ended up giving me. So I'm going to look to this one to see. I'm going to keep it the same. So I've got 2.085, and then my 10 to the negative second stays the same. That's the easy part about adding or subtracting with significant figures. And then my meters cubed stays the same. So again, the reason why I've got 3 digits here in my decimal places is because whenever you add or subtract significant figures, you're going to look at your smallest decimal place. And here it was right there, right? 4 places over. And here it was right there, 3 places over. So 3 places over wins. So 1, 2, 3, 3 places over it was.